Right. So before we begin 2.2, once again, one revisit into not the domains and all, but some concepts. Say you are given, we used to speak about this, you are given sine of sine inverse x is, you would write a sine of sine inverse means you will cancel them and write what as x. You can write, but here you should see that if you should read this as a trigonometric function. This is a trigonometric function. Sine of something. What is the value of sine? What is the range for sine's value? -1 to 1. That is the mistake. Don't go pi by 2. You see this as a sine function. Sine theta is equal to, what is the value of sine theta? From -1 to 1. You can write this as, now this is behaving as a trigonometric function. This is x. I'm rather writing like this. This is x, means this is x. If x belongs to -1 and 1. In fact, -1 to 1 is the domain for this. Look, this x and this x are same. If you are freezing for this x as this value, then check this should also go here. The domain for a sine inverse function is always -1 to 1. Understood? Now, this is many times confused by children with this thing. Sine inverse of sine x. You will say, sir, this is also x, right? But now this is what? This is a inverse function. Sine inverse something is equal to x. Then I will say, this is x if x belongs to -pi by 2 to pi by 2. Just see. Sine inverse, whatever you're getting this side is known as the range. What is the principal range of sine inverse? -pi by 2 to pi by 2. And just check. Sine pi by 2 to pi by 2. And in the principle, when we were looking at the sine function, just look at the sine function, okay? Just look at the sine function. This is pi by 2 negative. This is -pi. This is pi by 2 and this is pi, right? The sine function starts like this and like this. Children, if you remember, you had made the sine function bijective from here to here. That means for a sine function, the input that you can give is only from pi by 2 to -pi by 2 to pi by 2. That's what you're giving. See, x is pi by 2. You can give an input. This is the input on the sine function. Whereas for the inverse function, you will be getting, is this clear? Similarly, if you get it like this, cos inverse x is equal to x. Tell me now, if x belongs to what? No need to memorize. Look at the function. It's a trigonometric function. Cos as a trigonometric function gives you output from where? The cos function is always dancing between -1. Remember this, children. Sine function and cos function just dance between -1 and 1. So here it will be -1, 1. This clarity has to develop, though it looks very simple. Similarly, if I have cos inverse of cos x equal to x, if, now look, now you are having an inverse function. Inverse functions range you are seeing. What is the principal range of the inverse function? 0 to pi. And in fact, 0 to pi is the domain for the trigonometric function to be bijective. Only then the inverse exists. Get the crux of it. So we say if x belongs to 0 to pi. If you want to enjoy this in graph, always play with graph. The problem is CBSE has got such a syllabus where they believe more in memorizing. You should be given graphing calculator. Then these problems become so beautiful. It's a pi by 2, a pi, a -pi by 2, and a pi. So cos function, cos 0 is 1, right? Sin 0, cos 0 is 1. So the cos function will be going in this manner and then in this manner. So if we are supposed to use a cos function and make it bijective, we make it bijective from this range 0 and pi. Here the function will pass the horizontal line test. This is the input. This is the input. And the input becomes the range. This will again reinforce your thought process on. Okay, let's see for a tan. Tan is the easiest. Tan of tan inverse x is equal to x. Okay. Children, for a tan function, what all can you put? Just imagine. A tan function, what is the throw out of a tan function? What does tan function throw out? It's a trigonometric function, not an inverse. What does a tan function throw out? If you still have doubt, you look at the tan graph. So this is 0, pi by 2, pi, minus pi by 2, and pi. Okay. Tan, sin 90 is 1, cos 90 is 0. So tan is never defined for pi by 2. The tan function is like this. Now look at the output of the tan function. The tan function goes on the positive y, goes on the negative y, which is the real axis. So here we will say if x belongs to R. Simple. Agreed? Now if we are given tan inverse of tan x is equal to x, if, now you see, in order to make it bijective, what all can you apply? Sir, the tan is just like the sine function, cannot enter this data and this data. So here we will say if x belongs to open interval negative pi by 2 to pi by 2. Is this getting clear now? Earlier you used to memorize, now you'll get the idea. I will have another tan function here also, see. I'll have another tan function here also. I'll have one more tan function here also. But for the principal part, I will always consider this and this. Fine? Okay. Can you go for cot of cot inverse x? What does the cot function throw? The cot function will also throw you the real numbers. Yes, the cot function looks like this. The cot function will be always like this, like this. The cot function x, if x belongs to real number. However, if we invert the function, cot inverse cot of x is equal to x, then we will say if x belongs to, it will be exactly the cos function with an open interval. See, 0 to pi, that means only between these two intervals I can use the cot function. Getting clear? The more you play with graph, the more your clarity will develop, so that you'll never forget. Cosec of cosec inverse x is equal to x if x equal to. Now cosec function. Cosec can take what all values, children? It can take the entire R except the region between 1 and -1. This thing in some books may write it in this manner also. See, it will be a negative infinity, which is always open, and we will write -1 closed, because cosec can take -1, union with +1 positive infinity, like this. Okay, let's see it with the graph. It becomes more interesting. Let's see with the graph. Pi by 2, pi, minus pi by 2 pi. Okay, let me first plot what is called the ranges first. Plus 1, minus 1. And let's plot the sine function out here. Sine 0, 0. This is the sine function. Now, how will be the cosec function? The cosec function will be will not touch. Cosec touches 1, but does not come in the region between 1 and 1. Got it? So if we are supposed to play with cosec, then how do you find the principal range? The principal range will be this and this. However, 0 is not allowed as an input. Clear? So we write cosec inverse cosec x is equal to x if, right? If x belongs to open negative pi by 2 to pi by 2 minus 0 as an which one? Square bracket. Sorry, square bracket. I missed it. Sorry, I missed it. Yeah, square bracket. You can give this value. Sorry, very sorry. And let's see the last one, that is sec. Sec of sec inverse x is equal to x if x belongs to the real number minus negative 1 to 1. And sec inverse sec of x is equal to x if x belongs to 0 to pi minus okay, let's take some 2.2. Let's see some when you learn differentiation, you will see sine inverse x differentiation is always 1 by root 1 minus x square. Whenever you see a root 1 minus x square, the x is always substituted as sine theta. So let's see some problems. Okay, so no, even your book has that issue. It's example 1, 2. Okay, they have made it 3 here. Okay, now we have got show that these all examples are important. Show that sine inverse 2x root 1 minus x square is equal to sine x. Is equal to sine x. Here, children, you have to first see that what is the right hand side that they are asking you to prove. They are asking you to prove it as a sine x. And you have a 1 minus x square. A 1 minus x square can always be used as a 1 minus sine square or 1 minus cos square, whatever it is. So you have to get sine x. So we make an assumption here. Let x be equal to sine theta. Now what you assume also depends. If it was a square minus x square, then we will assume x equal to a sine theta. If it is 1 minus, then you assume as only sine theta. X equal to sine theta. Okay, this is what we have assumed. So we can write our LHS as now sine inverse 2, and from here we can also write, so theta will be equal to sine inverse x. Clear? Theta will be sine inverse x. So you can write this as, instead of x now you put sine theta and you put root 1 minus sine square theta. I'm just substituting sine theta in place of x square. So it becomes sine inverse 2 sine theta. This will become cos theta. So 2 sine theta cos theta is sine 2 theta. Write those identities. You will need them in integration. Sine inverse sine 2 theta. This is your golden chance to again recollect them. Which is equal to 2 theta, which is equal to 2 theta is sine inverse x, which is your RHS. Same problem you do on your own. On this side we have, sorry, this is to prove 2 sine inverse x. So you prove 2 cos inverse x. Prove the same problem. Same LHS. 2 cos inverse x. Same question. Try to do. Idea would be the same. What would be the idea? Since it is given that we have to prove as, मत देखो ना, इसको देखो, book देखने से. Same question, just the RHS is different. Same question, just the RHS is different. So since you have to prove it as cos inverse, you take x as cos theta. So it will become 2 cos theta sine theta. Again, it will become sine 2 theta. So it will become 2 theta. This time theta is cos inverse x. Done? So these are called where you have to prove or show that. Our next type of problems we get in this exercise is simple form. They will give you some expression and you have to bring it under simple form. So what does simple form mean? I'll take one question and get to you. It says cot inverse root of 1 minus root x square minus 1. Children, in this problem, whenever they give you in question, they will always give you the principal range. This is a function whose principal range is this. This is not for you. It doesn't bother you much. Only in the question you write it. Otherwise, this is not correct as a statement. Okay. Now, whenever you are doing a problem of this type, you have to bring it to simple terms. Means everything inside, it has to come into simple terms. Means all these inverse have to go away. If your inverse has to go away, यहाँ देखो ना, छोड़ दो book. If your inverse has to go away, did you follow the question? Cot inverse 1 by root over x square minus 1 is, you have to bring it to simple form. Simple form means you are not allowed to have any inverse and all. Finally, some values. In order to get some values, you have to abolish this inverse. Do you agree? You can abolish the inverse only inside if you create a trigonometric function, which should be of cot only. Then only the cot inverse will cancel the cot and you will be left with the angle value, which is the simplest form. Did you understand what I tried to say? In these type of problems, the final answer cannot have cot inverse. So how do you abolish the cot inverse? By creating a cot inside. The cot and cot inverse will cancel and whatever will be inside cot, that will come out. That is the simplest form, right? So how do we now take it? So let's say in such problems, sec square theta. So 1 upon sec is what? Sec square theta minus 1 will become what? Tan square theta. Tan square theta reciprocal is cot square theta. So we're getting a cot. You have to come to cot. You buy, borrow, beg, whatever. You have to get a cot. So I say let x be equal to sec theta. And I know 1 plus tan square theta is equal to sec square theta. That means sec square theta minus 1 is equal to tan square theta. And that's the thing that I'm going to use in this problem. So I say this is equal to cot inverse 1 upon root sec square theta minus 1, which is cot inverse 1 upon sec square theta minus 1 is root tan square theta, which is equal to cot inverse 1 upon tan theta. Cot inverse cot theta, which is equal to theta. And what is the value of theta? Sec inverse x. Simple form. Sec inverse x. This is the simplest form. This is not a simple form. A simple form is where the angle is expressed of a function in a very simple manner. This is much more complicated. Now this looks easy. Let's see one more problem. Before we do that problem, let's write one trigonometric identity. Children, by now you have written what is sine 2 theta is 2 sine theta cos theta, right? Sine 2 theta is 2 sine theta cos theta. Okay. Now come to cos 2 theta. Now this is a very dangerous and very stylish identity. Cos 2 theta has got 4 different type of values. Hey, take it. It might be important also. Okay. If you want to express cos 2 theta in terms of cos and sine, then this is written as cos square theta minus sine square theta. If you want to express it only in terms of cos, then it is 2 cos square theta minus 1. If you want to express it only in terms of 1 minus no, the tan is the fourth one. Wait, cos 2 theta in terms of tan is 1 minus tan square theta by 1 plus tan square theta. Okay, this is this 1 minus cos theta is equal to 2 sine square theta by 2. Okay, from here it will come. So this is 1 minus sine 2 theta. Yes. Look at this formula. 1 minus cos theta is 2. 1 minus cos theta is 2 sine square theta by 2. So that means 1 minute, children, 1 minute. There's a small mistake. So you take cos that side, 1 minus 2 sine square theta by 2 is equal to cos theta. So I'm having cos 2 theta. So this should be 1 minus 2 sine theta. Yes, sorry. Did you get how I got this? 1 minus 2 sine theta. Cos theta, 1 minus cos theta is 2 sine square theta by 2, which means 1 minus 2 sine square theta by 2 is cos theta. So if you double this, if you double the angles, this becomes how much? Theta. And this will become 2 theta. These 4 you should know. When cos is expressed as sine cos, when cos is expressed only cos, when cos is expressed with sine, and when cos is expressed with tan. Okay? Based on this, let's take up one more. Express simple forms. Simplest form. tan inverse cos x by 1 minus sin x. Tan inverse cos x by 1 minus sin x. This function has a principal range of 3 pi less than x, 3 pi by 2. Yeah. X less than pi by 2. This is just to be written for the question purpose. Okay, let's solve this problem. Okay. Okay. Now here we will have a lot of formula application right from the formulas of cos 2 theta. Now this can be written as tan inverse. This is all trigonometric jugglery. Cos, I can write it as cos 2 x by 2. Means I'm bringing it in cos 2 theta format. Agreed? 1 minus sine 2 x by 2. Can I do this? Right? Tan inverse, this is like complex one. Cos 2. In terms of sine and cos, what we will write? Cos square theta minus sine square theta. So you will write cos square x by 2 minus sine square x by 2. Children, did you understand this step or not? Tell me. Right? This one we will break as cos square x by 2 plus sine square x by 2 is 1 minus sine 2 theta is 2 sine x by 2 cos x by 2. देखो तो, have you understood this step? Huh? Here. See what is the idea? Why I am done this? See, this will break up into a plus b, a minus b. This will break as a minus b whole square. Then some katakati will happen. Let's see that. Tan inverse. This breaks up as cos x by 2 plus sine x by 2 into cos x by 2 minus sine x by 2. And here it is cos x by 2 minus sine x by 2, then whole square. Okay, bacha? Further, I can strike this and strike the 2.
The bottom one is a minus b
Whole square, yeah. A minus b whole square. Clear? So let's go further. Tan has to be brought into terms of tan. Simple. Tan inverse. On top now I have cos x by 2 plus sine x by 2 divided by cos x by 2 okay, we have to get a tan. Divide numerator and denominator by cos x by 2. 1 plus sine x by 2 okay. Tan inverse 1 plus tan x by 2 1 minus tan x by 2. What is tan of pi by 4? 1. tan inverse tan pi by 4 plus, there is a 1 here also which is hidden. You are not seeing it. I have seen it. Did you see the tan on this side? 1 is always a coefficient.
Oh, okay.
Tan A. Actually, you don't need that. Tan A plus tan B by tan A minus tan B. You don't need that. Correct. Why do we need that? We don't need that. So we can just write it as, tan pi by 4 plus tan x by 2 divided by tan pi by 4 minus tan x by 2. What is tan A plus B? Tan A plus tan B divided by 1 minus tan A tan B. Here we need it. That was what was striking me. Something I have done wrong. Here I need it. Tan A plus tan B divided by 1 minus tan A tan B. Child, I need it here. 1 minus tan pi by 4 and tan x by 2. Now it's all right. ठीक है ना? Tan inverse. Hey, mom, dad had to pick it up. Huh? Why are you not picking it? Never do that. They always have attention. Tan inverse. Last step I'm not writing. I hope you have understood. You can cancel the tan and tan. The simplest form is if you ask me, I don't find any pleasure in these problems. But however, to make it the ones we were doing in the previous class, where we say that this does not come, so we have to transform this, there is a bit of thinking. This is what jugglery. You can do whatever you want.